Well, this is the problem of arrangement with different restrictions. So, in how many ways can 5 boys and 4 girls be arranged on a bench if there are no restrictions? Boys and girls alternate. Boys and girls are in separate groups. Annie and Jim wish to stay together. So, here we have 5 boys and 4 girls who we are going to arrange with different restrictions. So before going into the solution, let's first discuss if in this arrangement orders matter or not, or repetition is allowed or not. So whenever we use the word arrangement, it always relates to the order, because we can arrange different people, objects, or units in different orders. So every single order is different from any other arrangement. So here the order matters. And now, if what about the repetition? If the repetition is allowed or not here? So any particular person is selected once for any particular place. So here the repetition is not allowed. And whenever we have these two things in the situations, then we use permutation. Now let's move towards the different arrangements with different restrictions. So, in how many ways can 5 boys and 4 girls be arranged on a bench if there are no restrictions? Now, here we have no restriction. We can arrange these 5 boys and girls randomly with different orders. So, we can collectively discuss them. We would take in total, we have 9 people, whether they are boys or girls, it doesn't matter here. So, because there is no restriction on the different categories. So we have in total 9 people which we are going to arrange on a bench. So we have to arrange 9 of them. So here total number of objects or units are 9, and we have to arrange all of 9 of them. So the arrangement would be 9p9, that is 9 factorial. So 3,62,880 ways we can arrange these 9 people in different orders. In how many ways can 5 boys and 4 girls be arranged on a bench if there are boys and girls alternate? So here we have to arrange 5 boys and 4 girls that they alternate, like boy, girl, or girl, boy. So let's first have a look at these arrangements. So we have started with a boy first. So you can see here boy, girl, boy, girl, boy, girl, boy, girl, boy. So we can also start this with a girl. So let's start with the girl. Then we have girl, boy, girl, boy, girl, boy, girl, boy, boy. So you can see here the arrangement is disturbed here with 2 boys. They doesn't alternate. So we can see here the first arrangement is right and the second one is wrong. So we would proceed with the first one. So let's now see the possibilities for the selection of boys and girls at their places. So for the boy at the first place, we have in total 5 boys. So here we have 5 choices to select a boy at this place out of these 5 boys. So we can say we have 5 choices here. Now for the second boy in the third place, we have 4 choices to choose from these 5 boys, because one is already selected for the first place. Similarly, for the third boy, we have 3 choices. For the fourth boy, we have 2 choices. And for the last one, we have 1 choice. So here you can say it gives us basically factorial, that is 5 factorial. Now let's move towards the selection of the girl. So here the girl at the second place, the first girl at the second place, we have 4 choices for the selection of this place out of these 4 girls. So we can say here we have four choices. Now for the second girl in the fourth place, we have three choices to select from these girls because the one girl is already selected for this place. So here we have three girls left to choose from. So similarly for the third girl, we have two choices. For the last girl, we have one choice. So we can write it as for the boys, we have 5, 4, 3, 2, 1, which is 5 factorial. And for the girls, we have 4, 3, 2, 1, which is 4 factorial. And 5 factorial is basically 5p4, and 4 factorial is 4p4. And we would use product between these two arrangements because we have to select simultaneously both the boys and girls. So here in 2880 ways we can arrange these 5 boys and 4 girls as they alternate. In how many ways can 5 boys and 4 girls be arranged on a bench if there are boys and girls are in separate groups? So here we have to arrange boys and girls like that the boys be seated together and girls be seated together. So we can arrange them in two ways, that is first boy then girls or first girls then boys. So we have to arrange these 5 boys out of the 5 of them in different orders. So we can arrange them in 5p5 ways. That is, we have 5 boys and we have to arrange these 5 boys. Similarly, we have 4 girls and we have to arrange these 4 girls. So this is 4p4. So we can use sum in place of or, and similarly we have the same formula for the next possibility. So here in 5760 ways we can arrange the 5 boys and 4 girls in the given manner. In how many ways can 5 boys and 4 girls be arranged on a bench if there are Annie and Jim wish to stay together? Now here we have to arrange 5 boys and 4 girls, like one boy and girl that named Annie and Jim wish to stay together. So they can sit at different places but together, like at first place and here. So they can sit at different places on the bench but they have to stay together. So now first let's have a look at the arrangement of Annie and Jim. Here at the first place there is Jim and at the second place there is Annie, and it can be seated like first Annie then Jim. So here for these two we have two different ways to arrange them. So we can write it as 2p2, that 2 units, and we have to arrange these 2 units. So to be 2 different ways we can arrange them, that are 2 possible ways. So now we have to consider Annie and Jim as 1 unit because they have to move together. So we have in total 1, 2, 3, 4, 5, 6, 7, 8 units to arrange them. So we have to arrange 8 units at 8 places, and it would be in 8p8 different ways. So it is 2p2 is 2 factorial and 8p8 is 8 factorial. So let's multiply it. For in 40,320 ways we can arrange these 5 boys and 4 girls with the restriction that Annie and Jim wish to stay together.